Alright, before we go to the example, so I will recall back a little bit from the slide just now. So what is ANOVA? ANOVA is, what is the purpose of ANOVA? So ANOVA, we want to test the similarity between more than two population means. So we will use ANOVA. So in ANOVA, there's one-way ANOVA and two-way ANOVA. So why we call it as one-way ANOVA? Because you have only one factor, means that one factor you have only one independent variable. Okay, for example, I want to test, is there any difference if using different type of teaching method to the final exam results. Okay, so let's say I have teaching method online and I have teaching method lecture face to face, and I have teaching method only exercise. Okay, so this one we call it as teaching method. So the teaching method will be your independent variable. So the teaching method will be your factors. There's only one factor, which is the teaching method. And then here I will have the final exam result for 3 students. 100, 80, 90. 100, 85, 95. 95, 99, 70 for 3 students. Okay, this one is the results. So the final exam result will be your dependent variable. Is it different teaching method give you different final exam result? So you will have teaching method and final exam result. So the teaching method is your independent variable, also is your factor. The exam results will be your dependent variable. Okay, so in teaching method here there are 3 teaching method, which is online, face-to-face lecture, and exercise. So these 3 teaching method we call it as treatment, denoted by K. Right? So first you need to define what is your independent variable. Oh, my independent variable is teaching method. So the teaching method will be your independent variable. What is your factor? The factor is also teaching method. Okay, so and then what is the next question? What is your treatment? Treatment come from independent variable, come from the factors. So you have 1, 2, 3. So there are 3 treatment. K equals to 3. So you need to understand this one. Alright, so let's look at the example. Ta-da! Example 5.1c. Okay, we'll use color purple. Alright, example 5.1c. An accountant is analyzing the number of frauds detected in large firms by type of departments. A random sample of 5 firms was selected and the per number of frauds detected in different departments are listed as follows. So you have here different type of department. You have department admin, purchasing, and marketing. Is there any difference in the number of frauds? So let's say in admin department you have 1, 2, 3, 4, 5. Sample 5. So these are the number of frauds. So you have 2 here. First is different department, where the department you have administration, purchasing, and marketing. and then you have number of fraud. Adakah different department memberi number of fraud yang berbeza? Adakah number of fraud ini bergantung kepada different department? Okay, itu dia punya konsep. So, the different department here will be your independent variable. So, the number of fraud here will be your dependent variable. So, in independent variable, you have administration, purchasing and marketing. So, the administration, purchasing and marketing will be your treatment. So, how many treatment you have? K equals to 3. Okay, based on the data collected above, she has obtained the following Anova table. So, this is Anova table. So, this is the Anova table. Right, look at number 1. Number 1. Identify number of treatments and list all the treatment. Treatments come from treatments denoted by K. Treatments come from your independent variable. We have administration, purchasing and marketing. So treatment equals to 3. List all the treatment. You will have administration, purchasing and marketing. Done. Number 1. Check. Number 2. Determine the number of factors. So number 2. Determine the number of factors. Factors is independent variable. How many independent variable you have? Only 1, which is the department. So factor 1. Alright guys, before we continue question number 3, by using conventional method, can accountant conclude that there is a difference in the mean number of frauds in the 3 department at 95% confidence level? So before we go for that question, we investigate the Anova table first. So you need to know how they get these values. Right, as mentioned earlier, this one is SSTR. Normally SSTR will be given, and this one is SST, and normally also SST will be given. So this one is SSE. How do you get this SSE? Okay, the SSE is equals to SST minus SSTR. So 18.9333 minus 6.5333. You will get the SSE. So how do you get this one? This one 2. 2 is because K minus 1. Our K equals to 3. 3 minus 1 equals to 2. How do you get this 14? This one is N minus 1. Total data is 15. 15 minus 1 is 14. How do you get this 12? This 12 is 14 minus 2. Degree of freedom total minus degree of freedom treatment. Degree of freedom total minus degree of freedom treatment. You will get degree of freedom error. Okay. Next, how do you get 3.2667? MS treatment is equals to 6.5333 divided by 2. How about MSE? 1.0333 is equals to 12.4 divided by 12. And lastly, how do you get the F-test? F-test is MSTR divided by MSE, which means 3.2667 divided by 1.0333. So this is the calculation. How do you get the value in the Anova table? Okay, let's proceed. By using conventional method, can the accountant conclude that there is a difference in the mean number of frauds in 3 departments at 95% confidence level? So alpha is 0.05. Step number 1 is your H null and H1. H null, how many K we have? We have 3K. K equals to 3. So we have mu1, mu2 and mu3. So mu1 equals to mu2 equals to mu 3. Or you can write down all population mean is equal h1 mu I not equals to mu j for at least 1i not equals to j. Or you can write down at least one population mean is different. Okay, step number 2 is your statistic. F test is equals to 3.1614. Okay, step number 3 is the critical value. How you want to get the critical value? Look at the F. Alpha is 0.05. Nu1 is 2 degree of freedom. Treatment. Nu2 is 12 degree of freedom. Error. Okay, our alpha is 0.05. Nu1 is degree of freedom. Treatment. Nu2 is degree of freedom. Error. So Nu1 is 2. Nu2 is 12. Okay, F 0.05 to 12. How do you want to get this value? Look at your stat table. Go to this one, table 7, percentage of the F. This one is your alpha, this one is your Nu1, and this one is your Nu2. So find alpha 0.05. So alpha 0.05 is located here, page 54. Our Nu1 is 2, our Nu2 is 12. So the midpoint will be here, 3.8853. So answer here is 3.8853. Right, then step number 4. Reject or accept H null. We will reject H null if F test greater than F critical value. Reject H null if F test greater than F critical value. So our F test is 3.1614. Since F test is equals to 3.1614 is less than F 0.05 to 12 equals to 3.8853. So reject or accept, because our F test now is less than. Do not reject H null because our F test is less than our critical value. So step number 5, the conclusion. At alpha 0.05, so your conclusion, you do not reject H null. So you do not reject H null, you accept this H null. So the mu is similar. At alpha 0.05, there is no difference in the population mean, number of fruits in the 3 departments.